All right, so we've got this reaction between iron and oxygen to produce iron 3 oxide, right? So oxidation, which is the loss of electrons. So maybe we'll write this out with our charges first to kind of figure out what's going on, and then figure out what's the oxidation half, what's the reduction half of this reaction. So anything that's a pure elemental solid, right, always would have an oxidation state of 0. So iron is 0. Oxygen would also start off as 0 because it's oxygen bonded to oxygen. If we're going to break down iron 3 oxide, right? So to break this down, we'll just break down, we'll break down all of them together. So I'd have 4 total irons, right? 2 times 2 is 4, and then 2 times 3, I'd have 6 total oxygens. So here's where it gets tricky. Iron can be 2, iron could be 3. We don't know. What we do know is oxygen is always -2. So, all right, I've got 6 oxygens at -2 each. So that's a total charge from oxygen that would be -12 overall. The whole thing needs to be neutral, right? It needs to be add up to 0. So that means my charge from iron needs to be a +12 total. So what would we assign to iron to balance that out? Yeah, +3, right? So, all right, oxidation is the loss of electrons. So what's being oxidized in that reaction, right? And reduction being gain of electrons, what's being reduced in that reaction? Yeah, Grace. Yeah, right. The iron is undergoing oxidation because we've got 4 irons that start off at 0, and they're somehow going to form 4 irons that are 3+. They're doing that because they are losing 12 electrons total, right? Both sides, I cannot create or destroy charge, so I'm 0 on the left. I need to be neutral on the right as well. So 4 times 3, we're +12. Okay, I've got a -12 with the electrons to balance that out. So there's my oxidation half reaction. I lost electrons there. The reduction half reaction, right? You've got 3 oxygens that are 0 each. We're going to add in a total of 12 electrons. And that's going to take us, right, once we think about it as an ion, it's going to take us to 6 total oxygens at 2- each. So again, we've got a balance of charge. We -12 charge on the left, and overall -12 charge on the right with our oxygen. And reduction is the gain of electrons. In thinking back to this question or a similar question that was on the exam, many people, this was kind of an interesting observation again, for me from an educational standpoint. I think it was like magnesium reacted with something. It was the MRE reaction. Many people identified a product, and that was a choice, right? C and D were both products of the reaction. Many people identified the product as undergoing oxidation or reduction. And so always in these redox reactions, we're not really focusing on the product. We're thinking about, right, the reaction is taking place with one of these 2 reactants. So we won't ever write the product, right, as what's going under oxidation or undergoing reduction, because that's the product of that reaction. That's the product of oxidation. It didn't get oxidized itself, right? The starting material got oxidized. It didn't get reduced. The starting material got reduced. So about 20% of the class actually answered the product of the reaction when it has to be one of the 2 reactants, because that's what's undergoing the reaction. The product is the end result of the reaction, but not where the reaction was occurring. The reaction occurred with iron. Iron lost electrons. Oxygen gained those electrons. We wouldn't say the iron 3 oxide was oxidized because it's the product of oxidation. So hopefully that helps in kind of like a similar question. Yeah.
Reduction is the gain of electrons and oxygen lose electrons.
So we're gaining, right? Electrons are negatively charged. So to go from 0 to -2, we're gaining negatively charged electrons, right? And so to go from a 0 to a positive charge, we're losing those negatively charged electrons. Yeah. Yeah.
That's pretty.
That's where it's flipped, right? The oxidizing agent causes oxidation, it itself gets reduced, right? So this would be the oxidizing so we would still, right, we're going to still, like, oxidizing agent and reducing agent, we're still going to categorize our reactants as those, because that's what's initiating the reaction, not the product of the reaction. And so that would make iron our reducing agent, because that's caused reduction because it itself got oxidized. Yeah. Yeah, because it's oxygen bonded to itself, right? So number one, it has to be, oxygen itself has to be neutral. And I've got this diatomic oxygen. I can't assign a charge to one of those, because if I called the one on the left -2, the one on the right would have to be +2, because together they're neutral. So that's why the whole thing, any diatomic will always be neutral. So hydrogen would have a 0 charge, right? Chlorine would have a 0 charge, because I can't assign charge to the one, because it's bonded with another element of itself. So if I assign charge to one of those, that means the other one would have to have the opposite charge. Why would it make sense for one hydrogen to gain an electron, the other one to lose an electron? So we don't typically we can't assign a charge in these cases where we have a diatomic. Why would one oxygen be -2 and the other one need to be, why would that be +2? And that's what we would need if we had to assign a charge. Because if they were both -2, well, then oxygen O2 should be -4, and it's not. We know it's neutral. Yeah. Yep. All right, that was a good one to review. A lot of good questions there.